Glove molding is another very common mold-making technique. Glove molds are easy to demold and ideal for casting materials that require quick cool-down. Glove molds are also economical from the standpoint that they use considerably less silicone. Glove molds can be made as a two-part box, one-part glove mold as shown in this video, or a two-part box, two-part glove mold. Glove molds are made by creating a mother mold around the master. The mother mold is made of a backing material such as plaster, urethane resin, or fiberglass reinforced polyester. With the mother mold in place over the master, the thickness of the rubber is controlled, resulting in a thin one-part glove mold. To illustrate the steps involved in making a glove mold, a Santa Claus figurine will be used. The mold is being built in a professional mold-making shop and will be used to cast a commercial line of figurines. The first step is to create a mold box. The mold box will support the fiberglass reinforced polyester mother mold. The figurine is measured. 1 5/8 inch clearance is allowed between the sides of the box and the master. The mold box is designed as two equal sections or halves that can be secured to a baseboard. During the mold making process, it will be cut in half, taken apart, and reassembled several times. Screws, nails, and staples are used to construct the box. The figurine needs to be mounted to the baseboard. The base of the figurine is sanded to ensure that it will be flush and level. Multiple screws are used to attach the figurine to the center of the baseboard to ensure future alignment. When making a glove mold, it is very important that the master cannot move, pivot, or shift once it has been mounted. A single screw would act as a pivot point, allowing the figurine to twist or turn. Release agent is now applied to the figurine. A 10% petroleum jelly and 90% naphtha solution is used. Compressed air evaporates the excess solvent and leaves a thin coating of petroleum jelly on the master. The back half of the mold box is attached to the base. The next step involves embedding half of the master into soft clay. Wood blocks are used as filler, and clay is added until only the front half of the figurine is visible. At this point, severe undercuts and extreme projections are reduced by adding clay. Now a smooth 3/8 inch layer of clay will be placed over the surface of the master. This step is very important because the thickness of the clay will determine the final thickness of the silicone mold. A uniform thickness of clay is achieved by rolling the clay between two 3/8 inch pieces of wood. The clay has been softened by warming it with a small heater or heat lamps. Use caution when warming clay because too much heat can make the clay very hot, even to the point of causing severe burns. The edges of the clay are carefully smoothed out and a clay cylinder is formed at the top of the master. The clay cylinder will become the pour spout into the mother mold. The front half of the master is now completely covered by a uniform thickness of clay. There are no undercuts and no projections, just a smooth, gentle contour. Release agent is applied to the clay. The solvent in the release agent breaks down the clay, helping to smooth it out while removing fingerprints and other imperfections. Release agent is also applied to the mating surfaces of the mold box. Mating surfaces are the edges of the mold box that come into contact with each other when the box is put back together. The front half of the mold box is now put back into place and secured. The next step is to make a mother mold. Fiberglass reinforced polyester is used to create the mother mold. The fiberglass is carefully layered and smoothed over the clay, extending 1 inch up the sides of the mold box. A total of 2 layers of fiberglass is used. Care is taken to make sure that all bubbles are removed and layers are completely smooth and of uniform thickness. Stray threads of fiberglass that are not smoothed out will harden into sharp, needle-like projections. After the fiberglass is hardened, the mold box is turned over and the back half is removed. The wood blocks and clay are removed. The same techniques are used again to apply a 3/8 inch layer of clay over the exposed backside of the figurine. An extra strip of clay is added down the backside of the master. This is where the rubber will be cut for demolding, the predetermined parting line. To ensure that the two halves of the mother mold do not stick to each other, the exposed fiberglass surface is coated with a 50% petroleum jelly, 50% naphtha solution. The extra thickness of release agent will prevent fiberglass from sticking to fiberglass. The techniques for creating the second mother mold are identical to the first. After the fiberglass has hardened, both halves of the mold box are removed. The layer of clay that was used to cover the master is now removed and set aside. The clay will be weighed to determine the approximate amount of rubber needed to make the glove mold. Each mother mold is thoroughly cleaned using solvent and a wire brush. Air pockets and pits located inside each mother mold are filled with clay to create a smooth contour. The two mother molds are clamped together and a pour hole is drilled into the top of the mold box. The figurine is now thoroughly cleaned to remove dirt, debris, or clay. The master is aligned with each mother mold to check for sufficient spacing. Release agent is applied to the inside of each mother mold as well as the master. The mold box is reassembled around the figurine and clamped together. A short piece of PVC pipe is glued to the top of the pour hole to aid in filling and serve as the reservoir. Release agent is applied to the inside of the pipe. The seams of the mold box are sealed with clay to prevent the rubber from leaking. It is now time to pour the silicone. The clay that was removed from the master is weighed to determine the approximate amount of rubber that will be needed. Dow Corning HS3 RTV high-strength mold-making rubber will be used to make the one-part glove mold. The material is weighed, mixed, and de-aired, then slowly poured into the mold. A light placed behind the translucent fiberglass shell shows the rubber flowing into all the spaces. The mold is gently rocked to help remove air pockets. The silicone is poured until it fills the PVC pipe. The extra rubber in the pipe acts as insurance in case any of the silicone leaks from the mold box. The silicone is allowed to cure for 24 hours. Before the mold box is opened, hinges and spring-loaded sash locks are attached. The edges of the mold box where the two halves meet are sanded to eliminate any offset. The hinge and locks assure that the two mother molds will always be in perfect alignment. The mounting screws are removed from the figurine and the box is pried open. The master is removed and excess flashing is trimmed. The figurine is demolded by cutting the rubber along the predetermined seam line using a curved blade knife. The blade of the knife leaves a tongue and groove type of seam that is self-locking when realigned. To make a reproduction with this one-part glove, place the mold back into the fiberglass mother molds, realign the seam, close and lock the mold box, and pour the casting resin. A plaster reproduction was cast from the mold to show the results. The next section will show the fabrication of a two-part block mold using the same technique of fiberglass support shell. This is a two-part block mold created from the base of a lamp. For this project, Silastic S was used. Silastic S is an addition cure product. It has high tear resistance, low durometer, low viscosity and high inhibition resistance, and is green in appearance. The techniques used are much the same as for making a glove mold. We pick up where we are removing clay from the second half of the mother mold. The first half has already been created and removed. A pour hole and air vents are now drilled into this half. To control tolerances, the rubber will be permanently attached to the mother mold. This will be accomplished with Dow Corning 1200 Prime Coat. The primer is applied to the inside surface of the mother mold. The primer will chemically bind the rubber to the fiberglass. The mold box is reassembled and a short piece of PVC pipe is glued into the pour hole, creating a pour spout. Release agent is applied to the inside of the pipe. Non-sulfur modeling clay is used to seal all the seams in the mold box before the rubber is poured. After mixing and de-airing, the rubber is then slowly poured into the spout. As the rubber reaches the air vents, small pieces of clay are used to plug each hole to prevent the silicone from escaping. After the Silastic S is cured for 24 hours, the back half of the mold box is removed and the same steps are repeated to complete the two-part block mold. A plaster reproduction was cast from the two-part block mold to show the results. Besides block molds and glove molds, there is another popular method to make a reproduction from a master. It is a skin mold, or brush-on skin mold. A skin mold is economical for large originals and easy to demold, even with complicated designs. This is a quick overview of the steps involved in making a skin mold. Dow Corning HS2 is most commonly used. Thin layers of catalyzed, de-aired silicone rubber are brushed or sprayed over the surface of the master. These are referred to as the print coats. Usually 2 or more print coats are applied. A layer of silicone rubber containing a thixotropic additive is applied over the top of the print coats. The addition of the thixotropic additive to the catalyzed rubber changes the silicone from a flowing to a non-slumping rubber. Separating shims are positioned into the silicone rubber at strategic locations where the mold will be sectioned. A backing material such as plaster, reinforced with sisal hemp, urethane resin, or fiberglass reinforced polyester, is used to make a mother mold. The mother mold is removed from the master in sections. The silicone rubber is cut along the shim lines and removed from the master. The sections of rubber molds are then placed into their respective plaster mother molds. To cast into the skin mold, reassemble the mother molds and lock together. In no-foundry applications such as restoration, casting material is poured into the skin mold to create a reproduction. The skin molding method is widely used by the art foundry industry. However, it is just one of the many steps in the lost wax process used by this industry to create bronze statues. In the art foundry industry, many of the objects to be cast into bronze must first be reproduced to life size or even larger. During the enlarging process, a variety of materials are used, such as chicken wire, iron rods, and urethane foam. The final near likeness is created in clay. An artist will complete the enlarging process by sculpting the final detail into the clay. The next step is to apply a skin mold to create a detailed negative. This is usually accomplished in 2 phases. First, thin layers of catalyzed, de-aired rubber are either brushed on or sprayed onto the master. These are referred to as print coats. Good print coats are important to ensure all the details of the object are reproduced. The print coats can be brushed on or applied by spraying. Usually more than 1 coat is required. Because of the wide use of sulfur-containing clays used by the artists in this industry, only tin-cured or condensation-cured silicone rubbers are recommended. Dow Corning HS2 is widely used in this industry. When more than 1 print coat is required, the additional coats should be applied after the previous coat is tack-free. Many mold makers wait until the previous coat is completely dry. Before the second phase of creating a skin mold begins, separating bubble shims are placed where the mold is to be divided. The number of pieces the mold will be divided into depends on its size and configuration. The second phase is to build up the thickness of the silicone mold to approximately 1/4 to 3/8 inch. This thickness is achieved by adding a thixotropic additive to the catalyzed silicone rubber mix. This additive turns the free-flowing mixture into a non-slump, easy-to-apply paste. The thixotropic mixture can be applied to the print coat without slumping or running off. The mixture is also applied to the separating shims. After the thixotropic coating is smoothed out and before the rubber cures, mold keys are placed on the surface at designated locations. The keys are cured pieces of rubber that aid in aligning the rubber mold back into its supportive shell. This shell is often referred to as the mother mold and is usually made out of plaster reinforced with sisal hemp, burlap, or fiberglass. With large mold sections, handles are often molded into this outer shell for ease of handling. The plaster mother mold sections are first removed from the mold. After the shims are removed, the skin mold is cut along the shim lines and removed from the master. The silicone skin molds are placed into their respective plaster mother molds. After each mold section has been reassembled, the next step